Good evening, Professor Thiel, fellow coal mining workers, members of the broader community, board members and shareholders, and of course a warm welcome to members of the engineering community. My name is Victor Odman, and tonight I'd like to talk about the use of AI in evaluating VA, which is vibration analysis in underground mining. So generally in an underground coal mine, this is the setup you'll see. You'll have a longwall, conveyors and mobile equipment. And the faults that we see from this are generally lubrication issues and equipment wear, but also blockages. Now what we generally do is we'll take current measurements from motors, and this tends to show us things like blockages, equipment wear to an extent, and to a lesser extent chain tension issues, which we have quite a lot of. What I'd like to do is actually look at using the vibration signature analysis, which has generally been used for lubrication issues. So we're talking about bearings, bearing faults, and equipment wear, and look at, amongst other things, there's a lot of other issues too, but say as picks wear out on the shearer, pick that up in vibration, or as we're cutting through a dike consisting of rock that's much harder than coal, picking that up and allowing the machine to make a decision based on these conditions. Now, data collection is really done by accelerometers that are mounted straight on the equipment, and this gives us a time series sample, generally up to with a bandwidth of up to 20 kilohertz, measured for a period of 15 to 30 seconds. An example right here. What we want to do is take a baseline when equipment is new, and then as the equipment is used in normal operating conditions, so running at full load, and as the equipment degrades or parts wear or break, we can then do, say, a mechanical overhaul or just an inspection, identify the parts that are wearing or failing, and then assign that failure mode to the errant signature, and thereby teaching the AI what it looks like when things are good and when things are not good. Now I suspect all the data, which is really just essentially this raw sample, will be stored on company servers using existing IT policies, and I do think that the data will probably be kept for as long as the equipment remains in use, and even after that will probably more likely be archived rather than deleted. In terms of stakeholders, we've got the mine workers themselves. Now, as I suppose the AI takes over the higher thinking, what we don't want to see is people being used as grunt labour without any option for them to upskill or essentially reach higher levels of advancement. For the community itself, being able to program can be done from an office or at home, and really suits people that may not suit working in an underground environment. Say, for example, you have claustrophobia, probably not a good idea to be in an underground coal mine, and even those with physical disabilities. And what we need to look at then is making sure that a proper work-life balance is maintained, even though, of course, being gainfully employed is a positive. In terms of the leadership and shareholders, yes, it's good to give back to shareholders, and that's what we should be doing. But maybe we should also look at providing some assistance to the environment that supports us as people. So I'm talking about water and land resources. And for the engineering community, the company, of course, wants to keep its data, and most likely will look at the intellectual property from the programming, but we also need to look at giving back to the community as a whole, just to make greater inroads into the programming and machine learning side of things. Thank you, anyone. If you've got any questions, please ask them now.